Good evening to everyone. Welcome to the CTET online coaching. CTET mathematics pedagogy classes. Today in this session we will be discussing about nature and language of mathematics. Okay. So particularly we are talking about how what is the nature of mathematics and language of mathematics. Why we call it is a language of mathematics and what is the key characteristic of mathematics. So coming to the next session, next slide. So we will be talking about covering meaning and definition of the mathematics. It is not just only talking about the meaning and definition. We will also try to understand so what exactly the mathematics and what are the different mathematicians has defined mathematics. And nature and language of mathematics, the key features of the mathematics, why we call it as a nature of the mathematics, what is the nature of the mathematics, and what is the language of mathematics, why we call it is a universal language of the mathematics. And also we will also see some of the teaching strategies such as like drill work, homework, oral, written. These are some of the techniques where student can inculcate in mathematics while learning. And some of the teaching strategies like group work, self-study, supervised study. So how group work is going to help for the student while learning mathematics, and how self-study is going to help for the student when they're learning mathematics. How does it going to help the supervised study? Are they going to become an independent learner through the supervised study? So in detail we'll be discussing in this session. And also the purpose of the assignment and the purpose of the brainstorming. So what kind of assignment we have to give and how assignment has to be given and how it is related to the concept assignment. How does it going to help for the student in learning. And also brainstorming. So what are the key features of the brainstorming? What are the advantages of the brainstorming and what are the disadvantages of the brainstorming, and how does it going to help in mathematics learning? And we also discuss logical and deductive reasoning. What is the logical reasoning, what is the deductive reasoning, and what is the inductive reasoning also. This is also we are going to discuss. Along with this we also going to discuss about the language of the mathematics particularly. So next, moving to the slide. So coming to the meaning and definition of the mathematics, there are some of them we may think that mathematics is only about the calculation. It is not about the calculations. Okay, it is way of thinking the mathematics. Maybe some of them think that mathematics only just doing the calculation like addition, subtraction, multiplication. So it's not about only just calculating the doing the abstraction, addition, multiplication. It is how we think logically, we reason out for each and everything. So that is what it represents the meaning of the mathematics. So here if you look at, so there are different mathematicians has they have given different definitions. Let us try to look at one by one. So Marshall H, he has defined the mathematics as mathematics is the study of abstract system built of abstract elements. So when I see that mathematics is the study of abstract, what is the meaning of abstract? Abstract means we cannot visualize the things. Suppose let us take one example. Okay, can we imagine what is the 2? Can we touch the symbol of plus, addition, subtraction? Can you see the number of 2? Can you see the number of 5? Can you see the number of infinite? No, we cannot see that. So we need to think about that. We need to visualize that. Okay, this is what the 2, this is what the 2. So that is what the abstract concept which is involved in the mathematics. So where it helps to learn the mathematics in more independent way. So Bertrand and Russell, he said that mathematics is neither knowing what we are talking about or whether what we are saying true. Exactly. So Galileo has defined that mathematics is the language in which God has written universe. So now without mathematics even we cannot everything it is depending on if you look at the nature of science. So if you look at even biology, if you look at even physics, even if you look at chemistry, so without mathematics these subjects doesn't exist. So wherever you want to calculate, like let us look at astronauts. Okay, if they want to calculate something they need to apply the mathematics. In the chemistry similar, if they want to identify something, okay, formula, they need to apply the mathematics. Even in physics, if they want to identify some distance, okay, they need to apply the mathematics. So therefore mathematics is the language in which God has written the universe. Okay, so that is what the Galileo is defining. In the log he said that mathematics is a way to settle the habit of reasoning in the mind of children. It is a way to settle the habit of reasoning. So where they try to develop the mathematics through the logical reasoning. They don't just apply the formulas and get the solution. They try to look at why this concept is existed, how I applied this concept, what is the purpose of applying this formula, this concept. So they abstractly they will think and they try to develop the logical reasoning through the mathematics. Mathematics is the science of measurement, quantity and magnitude. So when I say the science of measurement, if at all, let us look at, if you want to identify what is the size of the table, what is the length of the table, what is the breadth of the table, what is the height of the table. Okay, so we need to apply this mathematics, we need to measure, isn't it? So this also very important in mathematics, like quantity, how much, what is the quantity of milk, what is the volume of this water. So everywhere mathematics is involved. Without mathematics it doesn't play any role. Okay, mathematics is very important, where it applied in all the subjects. Now based on this, some of the previous questions where they asked, so like, to be in good mathematics one needs to, what is there are 4 options that are given. One is have mastery over calculations. The second option is create, formulate problems through the abstract thinking and logical reasoning and memorize the formula. Third option. Fourth option is remember solution. Now what they're trying to ask is, to be a good mathematics, one needs to, whether are they become a mastery over the calculation, or create a formula problem through the abstract thinking and logical reasoning, or memorize the formula, or remember the solution. Which one is correct? So if you become only master in over a calculation, do you think that you are a good mathematics? No, obviously. Calculation is just a part of mathematics, one of the skill which is very much important in order to solve the mathematics. But whereas second option, if you see, create, formulate the problems through abstract thinking and logical reasoning. So mathematics, the major goal of the mathematics is where we need to develop the child thinking process. That is what even our NEP 2020, NCF SC 2023 also talks about that. Even NCF 2005 also talks about where every child should be think mathematics in the form of mathematization, where they need to think and respond, when they need to develop their logical reasoning. Okay, so the creative formulate the problems through abstract thinking and logical reasoning. So this is the correct option. So why not memorize the formula? If you just memorize the formula, I know the sum of the formulas like a plus b whole square is equal to a square plus b square plus 2ab, or Pythagoras theorem, I know what. If I know only just formula, if I doesn't know that how to apply, way to apply this formula, can I become a good mathematics? No, we cannot. So just knowing the formula, we cannot become a good mathematics. We should also know how, where and why I'm applying this, why I'm applying this and that. If you know these things, then only you can become a good meaningful learning. Just remember solutions. So this is also not possible. Why it is remembering solutions? Every mathematics problem has a different solutions. Every problem is different, every mathematics solution is different. Okay, so now how many solutions can we remember? Can we memorize that? We cannot memorize all the solutions. Remember the solution is doesn't, if you just remember the solution, cannot become a good mathematics. So in order to become a good mathematics, you should, child should develop the creativity and and then formulate the problems through the abstract thinking and logical reasoning, where they need to develop their abstract thinking and logical reasoning. So when I say the logical reasoning, they need to investigate, they need to think logically, why I'm applying this formula. Why, suppose let us take 2 plus 2 is equal to, we say that 4, but why it is a 2 plus 2 is equal to 4. Okay, and then so such a kind of thinking process, logical reasoning we need to develop. So therefore then we say that create and formulate the problem to abstract thinking, logical thinking is a good to become a good mathematics. The second question is, the portfolio of mathematics student can have record of assignments, worksheets, maths lab activity, write-up of models, posters, cards, generalization. The second option is record of all class test and unit test. The third option is record of photographs and drawing. And the fourth option is record of classwork, notebooks, which is the correct option in this. Now, what is a portfolio? Portfolio means basically they, we have the misconception that we say that only it is a collection of the test marks. No, it is not just collection of the test marks. Portfolio is something overall comprehensive evaluation, where we do the child comprehensive evaluation. We try to collect how the child has learned, what child has learned, and what is the product of the child, what he has created. So in that such a manner we try to collect the assessment portfolio of the every individual learner. So now in the option 1, if we see record of assignments, yes, we provide the assignments to the students and we see that how the student has done, what he has learned from that assignment and how he has done the assignment and what is the product of learning outcome of from that. Worksheets we also provide after the class, every class we also provide the worksheets. So what kind of worksheet are we providing this, whether the student is able to solve the worksheet and how well the student has solved the problems, okay, fulfill the worksheet. And the math lab activity, so in the mathematics also as come like science, physics and chemistry and other subject activities, we also have the math lab activity. So when you give the project to the students, so when you give the lab activity, so how student is performed, like what is the learning from that one, and then write up of the models. Are they creating anything? Are they creating any posters? Are they creating any cards? Are they creating any generalization? How they're going to do the generalization? How they're applying all those things? So therefore, to portfolio means collection of all the records of assignment, worksheets, math lab activity, write up of models, posters, cards, generalization over a period of time. So then we say that portfolio is a method one can have all those things. So record of all class test and unit test, only record of all the classes and tests? No, it's not a collecting only record of all the class tests and unit tests, not a portfolio. Record of photographs and drawing, no, it is not only collection of the photographs, it's a part of collection of the photographs by writing, but it only the record of photographs and drawing is not a portfolio of mathematics student. And record of classwork notebook, this is also just part of the portfolio, but it's not only. The thing is that where we need to collect the record of classroom notebooks, okay. So portfolio means where we collect the record of the assignments, worksheets, math lab activity, write up the models and what kind of models, posters, cards, and lesson. When you student perform all these in over a period of time, when you collect and say the performance of the student, then we say that it is a this all things called the portfolio of mathematics student can have to comprehensively to assess the student. Now coming to the nature of the mathematics. So nature of the mathematics, it has its own language like mathematical terms, concepts, formulas and signs. So if you look at the formulas, we have the mathematics, we have the various formulas we have. So wherever you go, let us take the area of the perimeter, area of the circle, or perimeter of the circle, area of the triangular, area of the rectangle, area of the square, whatever it is. We have different formulas. We have length into breadth, all those things. So wherever you go, you will be trying to apply the same concept, same formula in order to measure the something area of the rectangle or area of the square. So similarly, we have the different mathematical terms, okay, and we have the different mathematical concepts, and we have different the signs like positive, negative, addition sign, subtraction sign, multiplication sign and division signs, okay. So these all things are which are involved in the mathematics. So where even if you are in India, even if you are in abroad, okay, so wherever you go, this all the signs are applicable, similar to everyone, every child, okay. Now if I ask the child to do the what is the 2 plus 3, they may say that 5, okay. Even if I ask some other student, they may say that 2 plus 3 is equal to. So now if I ask what is the 2 minus 1, they may say that 1. If I ask 10 into 2, they may say that 20, okay, 20. So these all addition, subtraction, these are the signs, addition signs, subtraction sign, multiplication, division sign, all signs are it is existed in the mathematics where it applicable for everyone. So converts abstract concepts into concrete form, okay, convert abstract concepts into concrete form. So abstract, when I say abstract concepts, where we need to convert this into the concrete form, like different, so where difficult concepts like such if you take like which I was talking, can you imagine the number of like imaginary numbers we have, and we have the complex numbers, we have the different like can you imagine the number 5 how it is, like no, we cannot. Can you have the physical objective for this one? We doesn't have that. So these kind of abstract concepts where we need to visualize and to put it in the concrete form. So mathematics does help to visualize this abstract concept to put it into any very easy manner concrete form, okay. Then third is develop the self confidence and self-reliance and scientific attitude, of course. So it is also nature of mathematics also helps to develop the self-confidence. Once you become a independent learner, once you develop your logical thinking, once you develop the abstract thinking, once you develop the logical reasoning, so you'll become a better learner, you'll become a self-reliance, and you also try to develop the self-attitude, so that where you can learn yourself, okay. And you also develop through the inquiry, why, when you apply one formula, why I'm applying this formula, okay. So why not other formula? You learn to inquire and you try to apply the formulas and you try to connect with the real life situation and try to develop the scientific attitude. So provides training in scientific methods. It also provides the training in the scientific methods where we learn the mathematics. So knowledge is exact, systematic, logical and clear. Once learnt, never forgotten. So knowledge is, so mathematics knowledge is, it is exact, it is a systematic. Of course, we have the mathematics, we follow the procedure learning of mathematics. Whenever you solve the problem, we try to follow a certain procedure. Like if you're trying to solve the problem in a sequential way, we try to give the first, let us take what is the given information, okay, what we need to identify, okay, what is the given information, what is the unknown information here, what formula I have to apply, what method I have to use. So we follow a systematic procedure in order to understand the mathematics. So behind that, we also have the logical and clear. So once we learn the procedural understanding of the mathematics, so obviously we will also try to understand the logical and clear. So we'll become much more logical, we try to understand it, and the solution become very much clear. So we are never forgotten. And even the rules, laws, formulas are universal, verifiable at any place and any time. So now we have the mathematical rules. Suppose if we take some of the rules, exponents, if we take some of the formulas, we are like a to the power of m by a to the power of n is equal to a to the power of mn. Okay, so like some of the algebra, algebra equations we have. Okay, so there are some of the laws we have, some of the rules we have, formulas we have. So these are universal for everywhere in the world. Okay, so it is applicable for even if you're in here in India, even if you're applying in Japan. So these rules are for everybody same. If you ask any student, so any mathematician, so these rules, laws, formulas are applicable for equally in mathematics. Develops ability of induction, deduction, generalization. So mathematics also help to develop the induction, deduction and generalization. So induction from, we'll take the examples of and we try to prove that, okay, suppose for example, let us take that there is a number, there are the numbers like 2, 4, 6, 8 and 10. Now from these numbers, what we can identify is that we try to say that, okay, for each and every number it is increasing by 2. So therefore we say that the number is increasing by the 2. So this is what, we take the examples and we try to generalize the statement. So whereas in the deduction, we have the, we say that, okay, so all numbers, for example, let us take, okay, we say that even numbers are divisible by the, even numbers are divisible by the 2. So for example, let us take even number is 10, whether 10 it is divisible by the 2 or not. Of course it is divisible by the 2, we will get the solution of 5. Okay, so therefore we take the statement and then through the examples we try to through that we apply the deduction, logical reasoning and generalization from based on this. Okay, now so when I take the addition like 2 plus 4 is equal to 6, when I say that, okay, 9 plus or 10 is equal to something 19. Okay, so when if you and again when it sum up the two numbers, okay, always it becomes again whole number. Okay, so like that. Okay, so maybe in different cases, like when you do addition, when you do the subtraction, when you do the multiplication, we have the different like addition, all those things. So when you try to do these all those things, okay, we try to based on the observation try to generalize that. Applied in physics, chemistry, biology and other sciences also. So of course mathematics exists in physics, it is exist in the chemistry, it is also exist in the biology, it is also exist in the other science subjects also. It is not only, so without mathematics this subject doesn't make sense. Even if you want to like measure something, even if you want to identify some, find something new in physics, we need to identify we need to apply the mathematics. Even in the chemistry we need to apply mathematics, even in the biology also we need to apply the mathematics. Now there are some of the teaching strategies in mathematics. Okay, so like suppose like drill work, what is the advantage of the drill work and what is the disadvantage, how it is going to help for the students. Now rapid memorization, automation of the process, learning by doing. Okay, so drill work will help you to remember the quickly, I mean it will help to develop the skills, mathematical skills ability, like where they can accurately speed, they can perform the calculations. So like, so let us take the table of the eighth table or fifth table, let us take. Okay, so when every day when you practice, like 8 ones are 8, 8 twos are 16, 8 threes are 24, like that. Okay, so when you try to practice every day, so when when a teacher asks immediately, it will become very quickly, very speedily, accurately, student would be able to respond for that. Automation of the process, that is once like student has respond very quickly, then we say that it is a automation of the process. Immediately quick learning, it will happen through the drill work, learning by doing. Okay, where we by performing the we try to learn the even mathematics also. So homework, it is the extent of the school learning, whatever we have teach, whatever we have taught in the school. So with connection with the real life daily situation, we try to extend the concept to make them to learn much more, applying in their real life situations. So extend the school learning, it cultivates the regularity and independent study. So so by giving the homework student, what basically it will help the students to perform the regularity in which help to practice the mathematics in every day-to-day life situations. Okay, and independent study. So through the performing homework, by doing the homework, so student would be able to become an independent learner. Then oral work, quick and easy start and tell alternates and discovers weakness. Okay, so where oral work, where when you ask the students orally, they may respond. Okay, easily they can tell that. Okay, so it becomes a much more alternates for the test. Okay, so where they can respond orally, so that when you ask them to give the orally, when ask them to give something, ask them to tell the oral, so students also try to develop the communication skills. Okay, so written work, precision, accuracy and retainable test, expression and writing power. Okay, so written work, if you see the oral work, it is only temporary. Okay, so when you ask something, he might say, when he respond the student, it will be only certain time, but as written work, it retain the longer time of period. Okay, so precision, so it means more accuracy, more procedurally they follow. Okay, the test and expression writing power, it improve through the written work. Group work will help the students to develop the cooperative learning and discussion and multiple perspectives. So when you discuss among the group, okay, so where they share their ideas individually, they share within the group. Okay, so one child may get the different idea, another child may get the different idea. Okay, so with that group work, what they exchange the ideas and they try to figure out which is the correct answer, which is the wrong answer, why we need applying this correct, why we are saying that this is the correct. Okay, so why not they try to develop their logical reasoning through collaborative learning. Self-study, independent learning, problem solving, attitude and heuristic thinking. So through the self-study, obviously the student will become independent learner, where they try to learn, develop their skills independently. They don't need to depend on the teachers or somebody else or friends. So with that, they become a much more independent learner. And problem solving attitude, they try to develop their problem solving attitude. So not only the mathematics, they also try to connect problem solving through in day-to-day life situations also. So they also try to develop the heuristic thinking. Supervised study, individual differences, teacher as a guide, removes demerits of the traditional methods. So when you study when you supervised study also, it will help the learner to develop their individual differences, where student is learn, they have the different learning strategies, styles. Okay, so in that case, what will happen, so teacher as a guide, he will be mentoring the students. So therefore you become a much more independent learner through the supervised study. Assignment, commitment, repetitive, review problems and promote the inquiry. So when you give the assignments, okay, when you provide the assignments, which assignments should provide related to day-to-day life expressions and day-to-day life situations, where they try to connect with day-to-day life situations and they try to solve the problem based on the concepts which you teach in the today's class. So like it becomes helps you to develop the much more commitment and repetitive and review problems and promote the inquiry skills of the students. And review of the concepts, emphasize thought over habit formation. Brainstorming, democratic, student-centered, higher cognitive objectives. So brainstorming also, so it becomes a student. Now the mathematics become a much more child thinking process, mathematization we call it. Okay, so now the mathematics learning, before it was a teacher center, now it becomes a much more students, and where we are giving opportunity for the student to explore themselves and solve themselves. So therefore we say that brainstorming is also will help to develop a logic, higher cognitive objective, higher cognitive learning. Okay, where they try to critically analyze the concepts and they try to evaluate, they try to develop the logical reasoning, they try to analyze, they try to figure out which is the correct. Okay, so therefore now it has become a student centered learning process. Now, what are the advantages of the drill work in mathematics? Learn material, retain longer and good for the beginners, and speed can be adjusted for learner. Accuracy of the learned material improves and memory of the child can be checked. Okay, so where is because through the drill work where student can develop their speed and accuracy when they're performing the mathematics calculations. Now if when I'm solving the problem, I want to apply some of the multiples of tables of the sum of the numbers. So I cannot just if I'm not mastering speed and accuracy in doing calculations. So even though if drill work and mathematics skills are very much important, we calculating the calculating very much speedy. Without if I'm not performing every day, if I'm not doing any everyday practicing, I may not get it immediately when I'm solving the problem. So therefore, in order to get the solution very quickly, formally speed, then drill work also very much important. What are the disadvantages of the drill work? It is not suitable for all the topics. Only certain topics only it will help you, like which I told some of the calculations like multiplications, additions, okay, to 2 digits addition, 3 digits additions, okay, and then mastery of the tables, okay, multiples of the numbers, okay, mastery of the squares, okay, mastery of the cubes, remembering all those things. And it creates a disturbance in other classes also. Ineffective without clear voice. Can become an exercise and academic futility. Okay, careful questioning by teacher needed. These are the disadvantages of the drill work. So now allow different rates and levels. Okay, then next, moving to the next, there is a one question which asked based on these concepts. One of the major reasons for student failure in mathematics at school level is that our assessment process. Option 1, emphasis on testing procedural knowledge than mathematization of the abilities. Is gender biased and ask problems relevant to the boy's interest? Is more subjective in the nature? Gives more weightage to the formative assessment? Which option is the correct one? Here let us try to understand. Okay. Now, what is the major reason for student failure in mathematics at school level is that our assessment process. Emphasis on most testing more and procedural knowledge than the mathematization of the abilities. So when you assess the student, we don't see just only the procedural knowledge, how they're performing. Okay, we also see how they're able to think. Okay, what is the mathematization of their ability, what is their mathematical skill, how accurately they're performing. Okay, how accurately they're trying to put each and every information in the mathematical language. Okay, so when I say the mathematical language, so when you ask like there are word problems which are there in the mathematics. Okay, when I ask you to read that problem and to convert into mathematical language, okay, so how they're able to form the equations like x plus 5 is equal to 10. Okay, so there is a boy, Raju having the 4 chocolates, or like X is more age of her father, like that. So when you take this kind of examples, okay, so how they're trying these word problems trying to convert into mathematic language. Okay, so this is a correct option. Is gender biased and ask problems relevant to boys' interest? No, never. In a mathematics, when you try to assess, okay, we never do that. Okay, is a gender biased? There is no gender bias. So assessment is equal for all the boys and girls. Okay, is it only relevant to boys' interest? No, it is not relevant to. So it is included both all the students which are involved in that. Is a more subjective in the nature? No, it is not more subjective. We also look at mathematics in terms of subjective. We also look at mathematics in terms of the objective. It gives more weightage to the formative assessment. No, both we have the assessment techniques where formative assessment is also there, and we also have the summative assessment. So there is no equal weightage we provide for the formative assessment, where we conduct formative assessment. So within the after completion of the chapter like unit 1, unit 2, and we conduct as a unit test. Okay, then we also do the summative assessment in order to promote the students. So formative assessment and summative assessment, both we provide equal weightage. Okay, so therefore because our assessment process emphasizes more on testing procedural knowledge, so therefore it becomes than the testing of the mathematization of the abilities. So therefore it is a failure. So the next question is, it is more useful to know how mathematics than to know the lot of mathematics. This statement is given by who is David Wheeler. Okay, George Paula, he talks about the problem solving. Okay, so it is a process of, when who is the process of thinking, and Vygotsky is not talk about the mathematics. Okay, so David Wheeler, he is the one person who talks about the mathematics, is that to know the lot of mathematics. Okay, then group work, self study and supervised study. So when you talk about the group work, homogeneous in intelligence and achievement, it promotes the competitive cooperation. Group work is best for the age of 8 to 12 years. And teacher content problem group evaluation or its constant, which is a more in a group work involved more teacher and teacher, where teacher provide the content to the students and problem to the students, and they where students they form the groups, and the evaluation or it's most of the constraints. So it is more in homogeneous intelligence and achievement, where individually they discuss, they put their ideas, same ideas discuss, and they try to come up with a solution. So it becomes leads to the better achievement in the. It also promote the competitive cooperation. Okay, so individually when they try to work in a group, okay, they try to develop their skills, ability skills. Okay, work group working skills and 21st century skills. So which is more useful for the 8 to 12 years. Self study. Individual learns independently without outside the help. Okay, so when I'm doing my self study, I will become much more confident, I will become much more independent learner. I don't depend on peers or teacher to to learn myself. Okay, so develop the heuristic and problem solving attitude. So when you solve individually problem in the daily day-to-day situations, obviously they try to become a problem solving, they try to develop that problem solving attitude. Okay, discourage cramming and best supplement to classwork. Okay, so whenever you give the classwork after listening the class, after attending the classes, so when the teacher give the homework or assignment, okay, so self study much will help you to solve the problems and develop their skills, mathematics skills. Supervised study based on activity, individual differences. It removes the demerits of the traditional methods. So it introductions, like where we have the different steps in the supervised study: introduction, instructions, supervision, and blackboard summary. It mistakes the corrected on the spot. So when you solve the problem in front of the teacher, in front of the guide, so where teachers scaffold you to reinforce, to identify your mistakes and try to correct you. So based on the activity, individual differences, so which is very important for the supervised study. It also remove the demerits of the traditional methods. Okay, when supervised study, what will help? So where individually teacher and student both are, learner will be learning in the presence of the teacher. So therefore, when the child is making a mistakes, errors, okay, so obviously the teacher will be scaffold, reinforce the student to correct what is the way of learning. Okay, so this is also help for the child. And then based on this, some of the questions which they asked, the term mathematical tools, it's referred to, there are 4 options which I have given. Mathematical tool means it is easy to calculator, rulers, tape measures, protractors, compass, etc. Or it is charts based on formula, graph papers, dotted sheets, etc. Or all type of materials, language, written symbols, meaningful instruction to establish in their purpose. And the option 4 is a physical material like geoboard and 3D models, cubic rods, etc. What is that? What they're trying to see here, trying to ask here. The term mathematical tools are all types of material which are include, okay, language and written symbols and meaningful instructions to establish their purpose. Okay, very mathematics has the as a universal language, we say that it has the written symbols. Okay, mathematics has written symbols, and it is a meaningful instruction to establish their purpose. So why we are applying these symbols, why we call it is a universal language. Okay, how we are applying, where we need to apply. So when you learn these things, when you try to apply these all those mathematization skills in a day-to-day life situation, so then it becomes a meaningful learning. So therefore option 3 is the correct answer. All types of materials. It is not only just the calculators, it's not just only the rulers, it is not just only the tape measures, it's not only the protractors or compass. Okay, mathematical tool which has all type of materials. Okay, it's not only the charts based on the formula, graph papers. It is help you only for certain concepts. So where you can protect the compass, calculator, we can use only for the certain concepts, not for the all, wherever it is required. Physical material like geoboard, 3D models and cubic rods. So this is also where we apply only for the limited concepts. Okay, you cannot apply for all the concepts. So here, but all type of materials. So materials which are there in the mathematic tool, okay, which is help to learn the mathematics for every in a different way everywhere. Okay, so therefore these all the materials are the correct answer for the meaning of the mathematical tools. The next question, contemporary understanding of mathematics pedagogy which encourage the teachers to do all of the following. Expect, develop. Option 1, develop the skill of systematic reasoning in students and encourage the ability to approximate solutions and introduce the computational problems before development of the conceptual understanding. Create opportunities for the student to guess and verify the solution to problems. So what they are asking exactly here, contemporary understanding of mathematics pedagogy encourages teachers to do all of the following, which is the except. Of course, so we also education, we also trying to develop the skills of systematic reasoning in students, encourage the ability to approximate solutions. It's not we're trying to find the exact solution, but we also try to see which is the approximate solution for the given problem, which is the nearest solution, which is the nearest answer. Okay, we try to develop the systematic reasoning, logical reasoning, we try to develop among the students, individual learners. And we also create the opportunity for the student to guess and verify the solution to the problems. Okay, once we get the solution, we also try to verify whether the solution is correct or not. Okay, but we don't just introduce the computation of the problems before development of the conceptual understanding. So this is the correct answer. Okay, then coming to the next, assignment and brainstorming. Okay, so assignment, what is the importance of the assignment and what are the two types of assignment we have? Let us see now. Okay, there are two types. One is the repetitive problems where the new work and teacher provides a variety of work, and the review problems like spiral assignment and revisit the earlier concepts. And these are the two types of the assignment where we have. Okay, so assignment also should be linked with the today's topic. Okay, now whatever I'm teaching in the today's class related to that topic, I should assign the assignment to the child where they can go and explore behind the learning, behind the classroom. Okay, where they try to do explore in their home. So for example, like I may teach the concept of today, length and breadth and area. Okay, identifying the of that concept. So I may give that after going the home, child has to be explore themselves in surrounding places or in their home. So what are the objects that are available in the home? Okay, and what is the length of that object, what is the breadth of the object, where they need to try to identify and come up with the classroom. Okay, so that is what the assignment will help you to develop their learning, become a much more independent learner, and it will help you to develop the much more better. Okay, good assignment must correlate with the previous knowledge. Assignment should be linked with the previous knowledge, and it must be very clear and definite and be motivating, not only simply dictation of the questions. It is not just only giving the questions, exercise questions like take the exercise question 1 2 5 and solve. It's not like assignment. It should be very meaningful. Okay, where they try to connect with the real life situations and involve the teacher and student cooperation. So where they both the teacher and student cooperation should be important when they're trying to do the assignment. So where they try to explore, they try to inquire, and they try to come up with the solution, whether it is correct or not, like how we can explore. Okay, how we can measure. So these are the aspects where we should cover when we are giving the assignment to the students. Brainstorming. Okay, when you talk about the brainstorming, it is a democratic and problem-centered technique where individual group of students sitting and talking, discussing about the certain topics or certain content. Okay, it is based on the modern theory of generalization. It is a content largely determined by the children. Okay, and the student express their views freely, teacher record on board, and based on the child learners better in groups than the individually. Okay, so brainstorming also have the disadvantage where they become much more problem-centered technique. Okay, which is student will help you to share their ideas and they try to learn, and based on the modern theory of the generalization. Okay, and content largely determined by the children, where they provide children itself is through the brainstorming, discussing with their individual ideas, and then they try to develop create the content. Okay, and then student express their views. Okay, so when one-to-one discussion happen, when we happen a discussion with in a group, certain groups, okay, they try to share their ideas and they try to express their ideas in order to become much more meaningful. Okay, so teacher records on the board, and teacher whatever the response getting from the students, where teachers record on the board and then try to discuss on that. Okay, so child learn better in groups than the individually. So instead of learning individually in mathematics, even in order to develop the mathematical thinking thinking, okay, mathematization. So where brainstorming is very much important for the in a classroom. Okay, so these are the advantages. Something problem oriented strategy. We provide a problem to the students where they inquire and they explore and they try to solve the problem. It achieves the higher order cognitive. Obviously, when they try to discuss among the groups, when they have the brainstorming about one topic with the different ideas, different examples connecting with the real life situations, so they become, obviously they try to develop their higher order cognitive skills and affective objectives. Provides more ideas and views of the child. So when you have the discussion within the group, okay, obviously the child will try to get from the based on the knowledge, based on the discussion, they try to get more ideas and they try to develop the views of the child. Then there are certain questions where they ask based on these questions. Let us see one by one. Which of the following statements regarding mathematics is true? One is that mathematics is a tool, mathematics is a form of art, mathematics is a language. Options A, B, C, option 2 A and B, option 3 B and C, option 4 only A. Now if you look at which of the following statements regarding mathematics too, of course mathematics is a tool. Yes, we have discussed now mathematics is a tool. It is compulsory where it involves everything in the it's not only the one part of calculation or skill. It involves where everything, okay, projects, assignments, everything. Mathematics is a form of art. Of course it is a form of art, okay, where we represent mathematics through the symbolically figures, okay. So therefore it's a form of the art. Mathematics is a language. It is a universal language where everybody can apply for everybody, every child, every learner. It is a in the world completely, it is a equal for everyone. Therefore we say that it is a universal language. So all options are the correct. Now question 8, if you see, which of the following is a narrow aim of teaching mathematics? Options: to make students proficient in handling numbers and number operations, to develop the student generalization abilities, to encourage the systematic reasoning, to develop the student ability to argue with the truth and falsity of the statements. Okay, so which is the correct response here? Okay, so now which of the following is the narrow aim of, so that means which is a practical, okay, broad aim is, narrow means very utilitarian, very practical, and broad aim is developing the reasoning and generalization. So now if you see that options, given options, to make students proficient in handling numbers and number operations, okay, which is the narrow aim of the teaching. But to develop the student general abilities are the broad aim, and to encourage the systematic, of course through the mathematics we try to encourage the students to develop their logical reasoning. We also try to develop the student generalization abilities when they find the solution, okay, when they find the answer through the problem solving, when they're trying to do the problem solving, we try to generalize that where we can apply this, okay, in which context we can apply and which formula we can use, okay, so in which situation we can use this. So we try to develop these generalization abilities. And the option 4 is to develop the student ability to argue the truth and falsity of the statements. We do not say in the mathematics classroom just whatever the teacher is saying accept and apply and follow the procedure. No, why we also try to develop the ability of argue with that, okay. Suppose if applying Pythagoras theorem, why I'm applying this Pythagoras theorem, what is my formula of this one, okay, where can I apply this Pythagoras theorem in my day-to-day life situations, okay, is this a correct example of my Pythagoras theorem, okay, is this a correct situation where I'm applying that? So we try to argue with the truth whether it is correct and falsity of the statements, whether it is statement, whether the formula is correct or not, okay, whether the given theorem is correct or not, whether the given facts are correct or not. We try to inquire, try to develop the inquiry skill, try to argue with that, okay. So therefore it is all 2, 3, 4 are the broader aims, and which is only the narrow aim. Now mathematics and logical reasoning. So we have the two, deductive reasoning and inductive reasoning. So deductive reasoning is the conclusions, reaching the conclusions from the previous known facts. We know the facts and we trying to reach them, based on the facts we try to generalize that, okay. So now that means now like sum of the even numbers always are the even numbers, okay. Now let us, I was telling like, okay, 2 plus 4 equal to 6, okay. So this 2 is the even number, this is the even number, this is also even number, okay. We say that the conclusion, we are trying to conclude that, okay, from the previous known facts. I know that, okay, some of the even numbers always become the even numbers, okay, these are the even numbers, these also even numbers. So therefore I'm trying to example and trying to see that, okay, concluding that based on my known facts. Conclusions are valid and it can be relied on. mathematical proof and sequence of the accepted logical steps from the axioms, and the fundamentals and different terms, axioms and postulates. So these are the where we try to use the deductive reasoning in order to learn when these concepts like fundamentals, like undefined terms and defined terms and axioms, postulates. When trying to prove the theorems, we take the we read the theorem, and then based on taking the examples we try to prove that the theorem is whether works or not. Okay, inductive reasoning, arriving at a conclusion based on the set of the observations. Okay, so we have the set of the observations and we try to arrive at the conclusion. Okay, not a valid method of proof in mathematics. It leads from the examples and theory that explains all the examples. So as we are discussing like this, okay, we take the some of the examples where we observe and then try to conclude that this is the correct. That is what inductive reasoning. So lead from the examples and theory that explain all the examples. And mathematics rely on deductive, not inductive reasoning for proof. Now, if you see the question, mathematical concepts form a complex web of connections in which new concepts and previously learned concepts are interconnected. Which statement best describes this? What is the statement they're trying to ask here? In the 2022, they asked this: mathematical concepts form a complex web of connections in which new concepts and previously learned concepts are interconnected. Okay, now let us see the options here. So that means fractions must be thought before the whole numbers. Second option, multiplication and division must precede addition and subtraction. Number concepts and pattern are building blocks of the algebra thinking. Previous concepts theory are redundant and must not be carried forward with the new concepts. So the option 3 is the correct answer, where number concepts and patterns are the building blocks of the algebra thinking. So when you want to solve learn the algebra concepts, when you want to learn the algebra thinking, okay, so for that what are the previous knowledge is required. Okay, we should understand the first number concepts. Okay, what is a number, what are the types of numbers, how we should understand, and we should also understand what are the pattern. Okay, all those things, then this becomes a base for the connection, for the algebra thinking. So others fraction must be thought before whole numbers. So whole numbers comes first and then comes the fractions comes the next. Okay, so first option is the wrong answer and second option is the wrong answer, fourth is also wrong answer. Okay, now next question, if you see, which statement is indicator of mathematization of the child thought process? Option 1, procedure and drill of the problems with the mathematics implies the mathematization of child thought process. Obviously it is no, because drill process, drill of the problems with the mathematics implies mathematization of child thought process. It is one of the skill, but it is not the indicator of the mathematization. Okay, this only just procedure and drill practice of the problems doesn't make the mathematization. Mathematization means where it is abstract thinking, where they try to put in terms of represent mathematics in the form of mathematical language. So mathematics education should focus on knowing how to mathematize rather than knowing a lot of mathematics. This is the correct answer. Okay, we are not just knowing how to calculate, how to get the answer. That is not the mathematization. We should understand the logical thinking, reasoning of mathematics. Then so that is what we say, that mathematics education should focus on knowing how to mathematize rather than knowing a lot of mathematics. And studying mathematics up to 12th would lead to the mathematization of the child mind. Obviously, so mathematics is not like this is only where till 10th till 12th we basic concepts where we do learn. So for mathematization, mathematics is a continuous learning process. Okay, so therefore it lead to the mathematization of the child mind. Okay, so this is also wrong answer. Child capable of solving complex mathematical problems in mind. No, this is also wrong answer. This not become a indicator of mathematics. Mathematization is not becomes. It's not only the child capable of solving complex mathematical problems in mind, where they need to put it in, and pen and paper also. Okay, project in different way of as a representation. Now coming to the second one, language of mathematics. So basically we say that as we know that we have different languages we have, like, okay, if you say the Indian, many languages are there. I may speak Hindi, I may speak Telugu, I may speak Kannada, I may speak Malayalam, everything. But we also consider that along with this, like mathematics also universal language, where we have the language, we have the formulas, we have the symbols, okay, and we have the syntax where we solve the language of the problem solving. Okay, so these are the key merits of the mathematical language, where it is well defined and clear. So wherever you go, wherever you apply, so all the rules and formulas, laws, everything applied into the mathematics. Therefore we say that mathematics is a universal language, where it develops the scientific attitude and draws the numerical inferences, and highly compact and focused and vital for the numeracy success. Now there are some of the questions where they asked in the previous CTET. Let us see this one. 4 stages of language development in mathematics. So what are the 4 stages of language development in mathematics classroom in order, or which is the correct order? We apply in everyday language, mathematized situation language, language of math problem solving, and symbolic language. The second option is everyday language and symbolic language, language of math problem solving, and mathematized situation language. That is the wrong answer. Now third option is everyday language and the language of math problem solving, and mathematize the situation language, symbolic language. That is also wrong answer. Now we have fourth option, everyday language, language of the math problem solving, and symbolic language, and mathematize the situation of the language. Now which is the correct order? So of course the option 1 is the correct answer, where first we start with everyday language. We try to observe in everyday day-to-day life situation, and the situation we that mathematical situation language we put it in terms of the mathematical language and the language of math problem solving, and we try to solve, we try to identify, and then we try to find the solution for that situation, and we represent in symbolic language. Okay, so this is the correct order of the mathematical language development in mathematics classroom. Okay, children, they move from everyday informal speech, applying maths to real life context, and the framing of word problems and abstract symbolic notations. These are so that is what happened in the option 1. Okay, which happen in the natural cognitive procession. Now the next question is the aim of encouraging mathematical communication. Which one of the following can be the most appropriate aim of encouraging mathematical communication in the classroom? So children who have fear about the mathematics should be able to interact in the class. The second option is to organize the debates in the class regarding the topics of mathematics. The session 3 is children should be able to recite theorems, formulas in a mathematics class. No. Children should be able to use a precise language while talking about a mathematical statement and using them. So fourth option is the correct answer. Why? Because children who have the fear about mathematics should be able to interact in the class. It's not compulsory. So which one of the following can be the most appropriate aim of action? So the aim of mathematical communication is where children should be able to use the precise language of mathematics while talking about the mathematical statements using, and how they're going to use this mathematical language when they're trying to convert word problems into mathematical language, and when they're trying to solve the problem, converting in terms of the symbols, converting in terms of the language, mathematical language. So only the fourth option is the correct. The option 1 is the wrong. To organize the debates in the class regarding the topics of the mathematics. So that is also part of that, but is not. Children should be able to recite the theorems forms in the mathematics class. No, it's not. Okay, so these first 1 and 3, 2 and 3 are the wrong answers, and fourth is the correct answer. Now next question. What is the mathematical theorem? A statement without sufficient evidence for proof. Our second option is a statement that has been proven by logical arguments based on the axioms. A statement which is always true and doesn't need a proof. A statement whose truth or falsity is not known. So if you look at the first one, a statement without sufficient evidence for proof, no, it is not. Wrong answer. Okay, so it describes only conjecture, hypothesis, not a theorem. But a theorem must be formally proved using the axioms and logical reasoning. This is the mathematical definition. So mathematical theorem means where it has the theorem, it formally we have to prove by using the axioms and through the logical reasoning. Okay, so that is what we have. Different theorems we have, like remainder theorem. Okay, so like different theorems we have. So when you observe those theorems in the geometry, when you see the different theorems, okay, we say the first theorem and we try to prove that through the logically by applying the logical arguments based on the axioms. Okay, and then a statement which is always true and does not need a proof. Okay, so this describe an axiom assumed to be true without proof, not a theorem. Okay, so axioms are just we assume to prove that true without the proof. A statement whose truth or falsity is not known, an open problem or conjecture. A theorem truth is already established. Okay, Then one more question. Statement is about the axioms. Read the following statement and select which are the correct. Okay, axioms are the propositions which are assumed. Okay, this is the correct answer. Axioms are the special theorems. False. No. Axioms are the definitions. No. Axioms when proved it becomes a theorem. No, it's not like that. Okay, so only axioms are the propositions where we assume and trying to prove that. And then which statement about mathematics is true? Okay, intuition has no role in generating mathematical knowledge. Mathematical statements can be conditional, and mathematics consist of the theorems proved in the mathematics books. And the option 4 is a person good in arithmetical computation, it is also good in mathematics and vice versa. Okay, so which is the correct answer? Second is the correct answer. Mathematical statements can be conditional. Okay, it's not a role in generating mathematical knowledge or other options. Now classify the mathematical statement. Common divisor of two integers is a number which divides both the given integers. Which is the correct statement? Second one. A definition assign the precise meaning to the mathematical term. This statement explain what common divisor means, and it is clearly a definition. Okay. Now teacher's algebra problem. So like there is one question which has given like this: does x is equal to y square intersect x is equal to y square plus 2? Test your conjecture, and does it hold for the x plus y square is equal to b? One learning outcome is comparison and analysis of quadratic equation. Okay, the teacher should focus only on getting the solution. The two graphs will not intersect. The teacher can assess the reasoning skill of the students. Such questions confuse student and should be discussed in a math class. No, it can be given. So option A and option C, option A and option C both are the correct answers. Where one learning outcome is comparison to analyze the quadratic equation here. Okay, and you also say if you see the section C, the teacher can assess the reasoning skills of the students. Okay, so therefore we say that A and C are the correct answers. So in this session we have learned about nature of the mathematics, language of the mathematics, what are the teaching strategies, what is the mathematization, and what is the strategy of hierarchy we use. Okay, what is the higher order thinking skills, and what is the inductive and deductive reasoning and assessment, how assessment help the students, and modern pedagogy of conceptual understanding before computation, like verify, encouraged. Okay, so these are the things which you have learned in this session. Thank you.